explaining it not clear enough. Or if people are more eager, maybe someone has a question, you can sort of tell based on the body language of the audience what they want to see or the mental state. So you can use that to improve your presentation. That's my suggestion.
Okay, thank you. Thank you so much.
Okay, I have two questions. First, I think I didn't know how to implement the AI agent. It's not included in 5G. 5G core, right? So can you tell me about that?
Okay.
I mean, to tell everyone want to know about it.
Okay. So our system actually have we in the free 5GC we use 2 VM for the test bed, right? For the core network free 5GC and also the run sim. But the LLM or the AI is not in the core.
Yeah.
So we move the AI because AI needs to have a lot of resource. So we use another VM which has a GPU. We use a DGX, if you know, it's a NVIDIA product. We use a local LLM server using the tool is called VLLM. And it is open.
Can you record this in your PowerPoint?
Oh, okay.
Or you did not show this?
Because the presentation is only for showing results, so we don't present the tutorial.
But do you include that that information in your reports?
Yeah.
Okay.
In the report have the architecture.
Because I think maybe the other students also want to know how to implement AI agent. Here is very hard topic.
This one.
Agent.
Okay. So we have the free 5GC web, and we have this MCP server, which is also the AI server. And this is the MongoDB, which connects. So this is the whole free 5GC, right? Or networks. It is its own VM. So and the free 5GC use MongoDB in the background, but it's not included in the core network architecture. So this is the web console for the subscriber management, and this MCP server is also included the AI agent for the LLM. So that's why the free 5GC connect the MCP server, because it is calling the LLM from this.
Okay, and another thing is because it's called autonomous network slicing, right? So once the system is under operation, the network slice maybe dynamically change the capacity.
Yes.
For example, in your examples, you have 33 users. But how about the user's number increase? Your system will automatically increase the bandwidth density.
So maybe that's our limitation, because like I say, the run side, the UE run sim cannot enforce the policy. That's why the LLM cannot know the parameters in the run. So that's why it cannot do an evaluation, an autonomous evaluation, because the parameters is not available.
Well, I want to say, like for example, your QoS quality of service is for 5 milliseconds, for example. That's for ultra reliable low latency communication, right? So once the quality is, for example, is higher than 5 milliseconds, your system should be able to respond to this change.
Yes, should be.
Right?
Yes.
Have you verified this?
Oh, just like
for example, we have 33 users,
yes,
right?
Yes.
So maybe we have 10 more users.
Yes.
So it causes the low latency. 5 milliseconds. So if your system will be able to respond to it.
It can respond, but like I said, we cannot demonstrate it because the LLM cannot how to say, get the data. Get the data from the subscriber in a way that, for example, in the system we create a URLC slicing, right? It's only less than 5 milliseconds, for example, and the system will try to apply the configuration to the UE, but the UE runtime, even though the GNB get the slicing profile, for example, the URLC, so the GNB knows that the slicing that needs to be used is the URLC, but when we test the UE, it's still not using the slicing configuration. So the GNB only receives the configuration, the slicing policy, but it's not applying the configuration to its system. So that's why, for example, the URLC doesn't need a high bandwidth, right? Maybe the bandwidth only 50 megabytes per second. But after the GNB receives the URLC slicing informations, and the UE also get the slicing informations, but when we test using iPerf3 and we test 1 gigabyte per second, the UE is still able to produce that many bandwidth, and not only 50 megabytes per second. And after we trace the code in the logs, the UPF and the PCF already state that the QoS already given to the the UE, but the UE runtime cannot. Its system doesn't have the dynamic slicing configuration. And you can also search about it in the UE runtime GitHub issue, because it's mentioned in there. So if we want to create a real autonomous response from the run, the LLM first of all needs to know the actual data from the run. But if the run cannot enforce the policy from the core, then the data is not valid. So we cannot.
So sorry to interrupt you.
Yeah.
Now I have a question. Let's say you were to disconnect the system. If you want to apply the changes, would you need to restart the UA runtime in order for it to take the new settings?
Sorry?
Like, do you need to restart the UE runtime for the new settings to take hold?
Yeah.
So like every time you need to change the settings, you need to restart the program, right?
In the UE runtime, yes, because we don't focus on there.
Okay.
But in the pre-5DC, if you want to add, if the system needs to add new classes, it doesn't need to reconfigure.
So it's just dynamic.
Yeah, automatically just doing
Okay,
it.
so your runtime is more static. Like it's just like a one shot.
Yes.
You set the settings and then you do a test, but you cannot replicate the changing settings without restarting.
Yes. That's why if we want to have a fully autonomous, we also need to change the UE runtime code. But I think it's out of scope for now.
Okay.
Okay, any other questions?
Okay.
I have a question. When you do your test with iPerf3,
Yes.
have you tried to check with Wireshark if the traffic is encapsulated in GTP? Because in my lab, when I do iPerf3 test, the traffic doesn't go through the GTPU tunnel. So when I see 20 gigabytes of throughput, I don't know how can you achieve this performance?
20 gigabytes?
Yeah. So have you checked with Wireshark if the traffic is correctly encapsulated?
Oh no, we haven't checked in the website actually, but because for the testing we don't deal with the outside network. If you know, the GTP is for connectivity between the UE and the internet side, right? So if the UE wants to access internet, it needs to go to the GTP tunnel. But since the testing we use is only local sites, so only in between VM, so that's why it doesn't need to go to the. It only need to go to the UPF, but not go to the GTP.
Okay, where is the iPro3 server? Where is the iPro3 server? You have a client and a server? Where is the server? In the Chrome network or in the
no, using only the local VM network. We use Proxmox, right?
Okay.
Yeah, so the VM uses Proxmox, so it used the Proxmox gateway.
Okay, any other questions? No, just thank you for keep Team 1. Team 2. Thank you, Team 3. Team 3. So next team will be Team 1. By the way, have you created GitHubs to keep your...
Oh yeah. I will show the link to you later.
Well, it's fine. You just keep it for yourself. It's yeah, but if you can share with me, that's great. Here I can share to the student.
Okay.
Can you share the link, GitHub link from the Moodle? Moodle system. Yeah. You share the GitHub link.
En fait, j'ai cherché Jérôme, mais il a capté un peu de champ pour DJ, je trouvais que ça me disait. En fait, ce qu'il fait. Je parlais de
Oh, right.
parce qu'elles sont préservées. Parce que je me suis rappelé ça. Parce que vu que vu que c'est des trucs un peu dessus, il faut. Du feu autour. J'ai arrêté,
Okay, yeah, you can start. You are ready. Hello, you introduce yourself first. Your name, Hugo.
Okay, so hello, I am Hugo. I'm from university from France, and there is Jules from the same university in France. So today we are going to present you the smart agriculture project. So this project is to make the farm agriculture more automated by using 5G. Because we use drones and sensors, so we need a 5G to connect all of them. Okay, so this project was separated in 3 steps. So the first step was the end-to-end network slicing. So we use 2 slices with the 5G, but we will see this later. After this, the second stage was to use Edge AI to trace all the data, etc. Locally. To make it fast. And the last step was the internet deployment. So we need to test the products. So to test it, we use 4 VM environment, and we will see the next slide. So the four environments work like this. So you get the one VM. So there is, you can see there is the drone and the sensor and with the antenna. Next, you have the Edge VM, so it tracks it's like a switch. It tracks the two slides. So after this, you get the core VM, so it's like the heart of the 5G. And after this, you get the compute VM. So it's there you have mosquito, all the camera and the AI who tracks the data locally. So there is the two slides. So the first slide is eMBB. So it's like the slides for the video. So you can have a lot of data on these slides. And the second one is the MMHC. So it's the slides for the sensor. So we separate it because they don't need the same amount of resources, and we need to separate it because it's better. So there you can see what the software do when we ping with the drones. So it goes like this: one VM to Edge VM to core VM to internet. So you can see there ping for internet. And after this, there is when it's the sensor. So you can see it only go to the compute server and stay on the farm. It will go on internet. You can see here the
So how we implement the architecture? So we need several UPF. The first one is IUPF. It's entry point, and we have 2 other UPF. One to go in the compute VM and one to go to the internet. So the IUPF and the PSA UPF are on the same virtual machine. So because they use GTP kernel module, we need to separate the 2 UPF in different Linux namespace and link them together with virtual RAM. So we have different services in the Edge compute VM. The first service is Media MTX. It's a RTSP server, so you can send many streams from camera, UAV, or what you want, and you can connect to this server to get the stream and analyze the video. So we have a YOLO app. YOLO is a small, prediction with AI. So we can in real time process the frame from the media MTX server and detect, for example, animals. The third service is Mosquito. It's a simple mosquito broker. So you can send data from IoT device to the broker. So the first demo we have do is MQTT simulator. So we try by using build NRU with the config file 35gcu IoT.yaml. We create 10 devices and we start the device with 10 seconds between each device. So each device can register at the right time. In the screen you can see we have 10 devices with 10 different IP devices. So to simulate MQTT traffic with only one VM, we use the IOMQTT client object from the Python IOMQTT library. So we can bind one client to one IP address and send our JSON payload on each interface. So we can capture the traffic with C# and we can analyze the traffic and see that the MQTT is encapsulated in the GTP frame, and we can see that we can see also this regrets that's not MQTT. So to simulate UAV, because the UAV can communicate with internet and the local next server, each UAV have two different PDU sessions. So for the UAV 0, you have two different interfaces, UOSIM UAV 0 and UOSIM UAV 1. The first interface is on the slice SST1. And the second interface is on the side SSH3. So they have different IP address, and you can ping different service. So with the first one, you can ping, for example, Google. So the traffic goes through IUPF and it's masquerades to internet. And with the second interface, you can ping the local next server, like MQTT or Media MTX server. And the traffic goes through PSA UPF to the edge VM. So to use FFmpeg to stream or simulate camera, we need to use another tricks with Linux namespace, because if you use FFmpeg only without Linux namespace, the traffic goes through the default gateway and doesn't take the tunnel from your SIM. So we bind each UAV to one kernel namespace with only one default gateway, so the traffic has only one solution to go to the server and use the correct tunnel. So we simulate a 4K video stream with 6.3 megabytes per second of stream and about 50 megabits. We can also check with C# if the traffic is correctly encapsulated. So we can see on top that the ECMP request to internet is encapsulated in GTP. Then we can see the traffic is decapsulated in the last IUPF and masquerade to the Google server. And if we ping the edge server, the traffic is encapsulated and is not We do different tests. So the first one is with Hyper3. We try to test the connectivity with Mac server. So each IoT device has a throughput limited to 10 megabytes per second, megabits. So you can see on the screen the Hyper3 test is limited to 10 megabytes per second, so it's much the requirement. We also try to test the latency between the different slices. So in this example, we have a pink device and 4 streams which start progressively. So in blue, we can see the throughput. So at the beginning, there is no stream, so there is approximately 0 byte per second. Then we start the first one, then 4 stream, and we can see with 4 streams the latency is very high. So there is a big impact in the latency. In the second example, we tried the same exercise, but we use 2 different slices. So the ping device is on one slice, and the 4 stream are on another slice, and we can see the same results. So there is an impact between slices. There is no isolation.
So we got some problems, some challenge. We got 4. So the first one was with the registration, because with FreeGC, when you want to make a new subscriber, you need to use the web device. But the problem with this is when you want to make a new subscriber, it's very, very long. When you want to make a lot, so for 50 subscribers, it's really, really long. So we just make a program, a script, who make all of the subscriber with Python, and it set up all the needed like automation. The second problem was because when you try to go on the internet, Linux wants to do the more fast way to increase the performance. So the problem is that Linux will not use our interface. It will just avoid the 5G, the 5G network. So to counter this, we just use network namespace, the Linux namespace, to force Linux to use the 5G channel and to have the correct the next one was about the ULCL, because the ULCL implementation from FreeGC so-called established ULCL only when selected SAT2 return non-sealed offer this time from PCI1. So to control this, we need to use the slice ID to split soon the data from the 2 slices, UDB and MMC. And the last problem was because we had, as I said, 50 subscribers. So to simulate all of the subscribers, because they are all sensor IoT, with just a single process, we can't do it because it takes too much performance and will just crash. So we use library. It's called it's this library Asyncio. We take all of this IoT and make it in one and make it more fast. Okay. So to